Hello everyone. In this final video of our RAG series, we are going to see it in action. We have talked about all the concepts: parsing, chunking, embedding, retrieval, and generation. And now it's time to put it all together with a real implementation. Let's walk through this notebook step by step. First, we are going to upload our PDF file on which we are going to apply RAG. So here is the PDF. And in next step, we are going to set up our environment variables. These are our API keys for accessing external services like Llamaparse, OpenAI, and Cohere. Make sure to insert your actual key here if you are running this yourself. Now, in next step, we are going to install our all required packages. So let's install. So we are installing all required packages. These include Langchain and related module for chaining the pipeline, Llamaparse for document parsing, ChromaDB and fast embed for storing and searching vectors, and OpenAI for LLM and Cohere for re-ranking. We are basically setting up our RAG toolkit. So let's move to our parsing phase. Now, now we use Llamaparse to extract clean and structured text from PDF file. Here we have specified the result type format, which is Markdown, and given our PDF path. LlamaParse offers a wide range of parameters, so do check it out. Here we got our parse document. This is the format of our text. Now let's move to our next step. This step simply pulls the raw text out of the parse document. We are preparing the content so it can be turned into format suitable for embedding. Now, we are going to convert each chunk of text into Langchain document object. This is the format expected by Langchain when creating embedding. After this, we are going to apply our chunking phase. Here we break down our long text document into smaller overlapping chunks. This helps us to keep important context, especially for queries that may relate to content and the boundary of two chunks. Here we have specified our chunk size up to 800 tokens and overlapping to 200 tokens. Overlapping ensures no critical information is missed when we search later. Now it's time to create embedding and VectorStore. We are creating embedding for each chunk using model from FastEmbed and store them in ChromaDB vector database. Each chunk becomes a semantic vector. This allows us to perform meaning-based search instead of relying on exact keywords. This step can be some time taking, so we have to wait for it. Now we can query the vector database using a retriever. Here we ask a question about potential energy and it will return top 3 most relevant chunks based on demand. Now we are going to set up our hybrid search model. Here we will define our vector store retriever and keyword retriever. Vector store retrieval will be retrieving two chunks and keyword will be retrieving one chunk. Now let's move. Now we use ensemble retrieval, which lets us give more weight to vector result but still include keyword matching. We can set this weight according to our need. Now we will be asking our hybrid retriever some query. So let's go. Here is the query. We are going to ask for hybrid search. This is the result what we get out of it. Now let's move to re-ranking part. Here we use re-ranking to fine-tune the order of retrieved chunks. Instead of relying solely on initial retrieval ranking, Cohere evaluates the chunks are most relevant to the query. We pass query and retrieve chunks and it returns reordered chunk based on semantic meaning. Now we are going to call an LLM. So here we use OpenAI language model to generate the final answer. But we don't just dump in the query. Instead, we carefully structure the prompt. The system message sets the tone. Here we tell the model to act like an expert physics teacher and only use the provided context. The human message includes the actual query and re-ranked context. Let's see if it can answer our question or not. Yes, here we got our answer. Yes. Now let's check in our textbook if it's correct or not. Here is our query and we are getting exact same answer. So your RAG pipeline just answered a query based entirely on your data, and that's it. You have built a full retrieval augmented generation system from scratch. Here is a quick recap. Parse raw documents, chunks them into meaningful sections, embed them as semantic vectors, store them in VectorDB, retrieve the relevant chunks based on queries, re-rank the result for sharp accuracy, and final step we are going to generate the final answer using LLM with full context. I hope this was useful. Thank you.